What you're looking at here is the completed power supply, and here are the two voltages coming out of it, filament and B plus, to prove it. We needed 90 volts B plus, we have 91.5. We needed 4.5 volts filament, we have 4.49. Right on, essentially. We took the basic design of the power supply, made a few changes. My mentor took me all the way through this. Boy, this has been a learning project for me. This was great, and I hope it'll be a learning project for others. We added a few things without going crazy. I didn't want to, completely alter the basic design that we started with. I wanted to stay as close to that as possible, but I wanted to keep a few safety levels around and added to it. So that's what essentially was accomplished. I only have one thing left to do. I've got to put. I'm using two 500 ohm resistors in series here. I've got a 1,000 ohm 2 watt resistor coming in. Should be in the next day or two. I'll take those out and change them. But we'll be taking a closer look at the power supply item by item as to what was changed from the original design for those of you who are following along. And our radio is playing fine. The only problem I have is I have a 4A6 tube. Half of it is a little weak and it's causing a little shuttle in the speaker. I don't like that. She's sounding real good. Tone's working. Okay, next time you see this, everything will be disconnected, and we'll go over item by item with the schematic to show you what we did. Here's the close-up look of the power supply. Earlier I told you we were going to add a Zener diode across the output. This is a 91 volt 5 watt Zener diode. We added it right across there. Now the cathode of the Zener diode goes toward the positive side of the electrolytic capacitors. What else have we done to this thing? Oh yeah, we added these round blue things. One here, one there, and we put a little green one here. The larger ones are rated at 170 volts. The small green one is rated at 17 volts. Now this is AC, of course. What they are is they're called MOVs, or metal oxide varistors. MOV. And they're all based on what's called RMS voltage. You need to look up RMS voltage if you don't know what it is and read all about it. It's not my intent to teach electronics theory here. I never want to do that. There are other guys on the YouTube that can do that much better than I can, trust me. Anyway, what we were having was we were getting voltage spikes, transient voltages, and they wiped out my voltage regulator here. It wiped out one of the full wave bridge rectifiers, and it also wiped out the little rectifier diode right here, the 1N4007. Wiped out all three of those things. I was not a happy camper. I don't know where they came from. But anyway, we came up with using RMS voltage calculations, put a 170 volt one here, which is on the input to the whole thing. So now if I get anything that comes up in here, a spike above 170, it's going to pass it on through the ground and let it go back. It won't wind up in the power supply. Now over here we have another output of 120 volts, and we went in, as I said, the spike wiped out my single diode. I went ahead and put another full wave bridge rectifier like that in here as a result of a suggestion of one of the viewers. And it worked pretty good, except it put out way too much voltage, way too much. So we had to go back to a single diode. And that's working fine, but the voltage spikes killed it. So we now have a 170 MOV, 170 volt MOV there also. So any spikes that come out of this transformer, just like any spikes that come down here, they're going to go through that thing over here to ground and go back. So that protects this circuitry here. This one here protects this circuitry over here and this power transformer here, and also this full wave bridge rectifier here, which comes down off the secondary. Now, just to be on the safe side, we went ahead and put a 17 volt one across here, because the output of this transformer here is 12 volts. So we put a 17-volt one in there. Any spikes that come out of the secondary will go through it and back down to ground also. Just protective devices is all they are. So we stayed pretty true to the original design of the power supply, which is what I wanted to do. Everybody gave me some good suggestions. You know, there's some good stuff in there for the rest of you to read. You know, somebody came up with some great ideas. We talked about it all. I say we're talking about Brendan and myself. We discussed this, discussed that. But I wanted to stay with the original design. That's what I wanted. I said that right from the beginning. This is the power supply we're going to build. And all the other stuff was great information, especially for other people to read. I found it very interesting. Some of you were giving me some wonderful inputs. There was no way I could do everything that everybody suggested, of course. So that's where we stand right now. You've already seen this thing demonstrated. It works perfectly. And all we added to it was we increased the resistor, added a Zener diode rated at 91 volts, 5 watts, put 3 MOVs in, and that was it. Everything else remained the same, which made me very happy. So next time, the next video, I hope to have this thing encased in a gray plastic box. If not, I may have to go downtown and find a larger box, because these two, incidentally, one more thing I did do. I changed transformers. Remember, I went from that small, puny little thing up to this larger one, which is identical to this. Works much better, much beefier. I don't think there's anything else I need to cover on this. Everything else should be fine. We've covered every capacitor, every resistor, and everything. If you have any questions, fire them along. Brendan and I will do our very best. You know, I can tell you about the construction and quite a bit on the theory now. This was an extreme learning experience for me. Brendan did a fabulous job bringing me along. But, you know, like I said earlier, you know, that's what a mentor does. He takes the dumb and makes them half smart. So I appreciate what Brendan did. And I will continue to drive him crazy, because that's what I'm supposed to do. All right, any questions, let us know. We'll do our best to answer them. Those of you who are building this power supply, good luck. You already know it works. I've shown you it works. It can be done. It's cheap, and it should last a long time. Like they used to say, works fine, lasts a long time. One more thing before we close it out. There's always one more thing. Don't ask me why. This is a 500 ohm 5 watt resistor, ceramic resistor that's in series with the 1N4007. I mentioned this in an earlier video. We left it in to cushion this rectifying diode. You know, as soon as you put power to this thing, we didn't want anything to be slamming against that diode instantly. So even though the MOV is there to protect us quite a bit, we went ahead and left the 500 ohm resistor in there. So I suggest you do the same if you ever decide to build this type of power supply. A little bit of WSM action here when I came home from work. Until next time, this is John.